for some time to let everyone join and then we'll start the session. hope I'm audible to all. Can someone confirm? Hello. Can anybody confirm if I'm audible? Okay, thank you. And can you guys see my screen as well? Okay. So, welcome all to the third day session for drug delivery principles and engineering. Okay. Welcome to the third day session for drug delivery principles and engineering. And as usual, we'll go through the topics that were covered this week and follow up with some assignment questions that will help you in solving week 3 assignments. So these were the topics that were covered in this week: controlled release systems, wherein reservoir systems and matrix systems were discussed mostly, and these matrix systems, in the matrix systems, further non-erodible systems and erodible systems were discussed. So out of these two main types of the control release systems, reservoir systems are basically systems where the drug is contained in a core surrounded by a rate controlling membrane, mostly a non-degradable membrane. And the matrix systems where is systems where the drug is dispersed throughout a polymer matrix, but it can be either non-erodible or erodible. So, and these reservoir systems, basically their release kinetics, some examples, and all were discussed. And then about hydrogels. Hydrogels are basically your 3D networks of hydrophilic polymers which holds large amount of water to mimic the extracellular matrix.
So hydrophilic polymers are basically uh, hydrogels are basically hydrophilic polymers made up of hydrophilic polymers that holds large amount of water without dissolving uh, due to crosslinks. And these kind of hydrogels are used for drug delivery systems. They absorb lot of water and swell, and that's how their pore size increases, releasing the drug contained in them. So based on these topics, there are some assignment questions that we'll go through now. So this is the first question: which two statements are false here? The options are: drug release from reservoir system is controlled by diffusion, drug release from reservoir system is controlled by bulk erosion, drug release from matrix systems is controlled by diffusion, drug release from reservoir system normally follows zero order kinetics, or drug release from matrix system normally follow a zero order kinetics, or drug release from matrix system normally follow first or higher order kinetics. You have to select two false statements here. Please let me know what you think the answer is, and then we'll discuss the answer. You can either unmute or write in the chat box. Is the question slide still not visible? Can you guys see my screen now? Okay. So this is the first question where you have to select two false statements regarding reservoir systems and matrix systems. Please let me know what you think the correct answer is out of these six options. Anybody? Option 2 and 5. Okay. Anybody else would like to answer? 2 and 5. Okay. Yes, both of you are correct. So the correct options here are: drug release from reservoir system is controlled by bulk erosion, and option 5, drug release from matrix system normally follow zero order kinetics? Yes, so in this question we have to select two false statements. And as I mentioned before, option 2 and option 5, drug release from reservoir system is controlled by bulk erosion, is a false statement. Mostly these reservoir systems use a diffusion control membrane and not erosion to control the drug release. And the kinetics, it follows the matrix systems. Basically, the drug release from the matrix system normally follows zero order kinetics, that is another false statement. The matrix systems normally follow a non zero order release, mostly first order, as the release rate decreases over time due to the concentration changes across the gradient. So, yeah, option 2 and 5 are the correct answer. Moving on to the next question. What are in situ cross linking hydrogels? Which of these is the correct option? Polymers cross-link at the site of injection inside the body. Okay. So this is the next question. What are in situ cross-linking hydrogels? You have to select correct option here. First option is polymers cross-links at the site of injection inside the body. Second option, cross-linked polymers are introduced at the site of injection. Third option is hydrogels which release growth factors upon stimulation by tissue microenvironment. Or fourth option, polymers which contract when inserted in vivo. Which of these is in situ cross-linking hydrogel? Has anybody answered? Option 1. Okay. Anybody else would like to answer? Yes, all of you are correct. In situ cross-linking hydrogels are basically polymers that cross-links at the site of injection inside the body. So in cases of this in situ cross-linking hydrogels, it's basically a polymer and a cross-linker, two different kind of solutions that are injected together, and based on some factor like temperature, pH, etc. Based on these, they cross-link due to the changes in these factors and form a hydrogel inside the body when injected together. Okay, moving on to the next question. So, physical hydrogels are polymer networks held together by which of these forces or bonds? 1. Neutral or ionic bonds, only covalent bonds, only hydrophobic interactions, only van der Waal interactions, only London forces, only nuclear forces, gravitational interactions, or inertia. Has anybody answered? Which of these? Option 1. Option 1 again. Anybody else would like to answer? Which of these do you think are physical hydrogels held together by? Okay, so the correct answer here is most of the physical hydrogels are polymer networks held together by neutral or ionic bonds. Most of these bonds, non-covalent bonds, basically non-covalent interactions like ionic or hydrogen bonding or van der Waals, these come under this neutral bonds or ionic bonds. Most of these forces will come under these two categories. That's why the first option will be the correct answer, that is neutral or ionic bonds. But they should be non-covalent basically. Okay, moving on to the next question. Moving on to the next question. In microporous hydrogels, pore size usually vary between which of these size ranges? Option 1. Okay. Yes, all of you are correct. The correct answer here would be option 1, 100 to 1000 angstroms. And this 100 to 1000 angstroms basically is 10 to 100 nanometers. So in microporous hydrogels, the pore size usually varies between these size range. Okay, moving on to the next question. Which of the following parameters is an indicator of polymer crystallinity? Options are Tm, Tg, Mw or Mn. somebody has answered TM. Anybody else would like to answer? Which of the following parameters is an indicator of polymer crystallinity? Okay. TM is the correct answer. So, the property that indicates the polymer crystallinity is the melting temperature, or the TM, and it is the temperature at which the crystalline domain in the polymer melts and loses its order structure, which basically defines the crystallinity. Whereas the other temperatures, like the glass transition temperature, it corresponds to changes between amorphous movement of the amorphous polymer chains, and MW and MN are the molecular weights. So molecular weight, average molecular weight, and the number average molecular weight. So they don't also define the polymer crystallinity. So the correct answer here would be TM, or the melting temperature. Moving on to the next question. What is lag effect for release of drug from a drug delivery system? The options are sudden release of drug from drug delivery system at the start, or delayed release of drug from drug delivery system after implantation, or timely release of drug from drug delivery system at the start, or the material lags in important properties like Young's moduli, or the drug is released spontaneously. Which of these is the correct option for the lag effect of drug release? Option 2. Okay. Most of you have answered 2. Yes, that is the correct answer. So lag effect is basically the delayed release of drug from drug delivery system after implantation. This mostly occurs because these kind of devices, if you have prepared it and kept it before putting it into your system, uh, the drug, or sorry, if you immediately put the freshly prepared drug delivery system into in vitro systems or in vivo systems, it will take some time for the drug to move from the core towards the periphery, and that is the lag effect that will be there, that leads to the delayed release of the drug from the drug delivery system after implantation. Okay, moving on to the next question. What method is used to measure surface roughness? Options are differential scanning calorimetry, two photon microscopy, dynamic light scattering, circular dichroism, or atomic force microscopy. Anybody would like to answer? What method is used to measure the surface roughness? Differential scanning calorimetry, two photon microscopy, dynamic light scattering, circular dichroism, or atomic force microscopy. Option 5. Okay. Yes, all of you are correct. Option 5, or atomic force microscopy, is the correct answer. Atomic force microscopy, or AFM, is used to measure the surface roughness. It has a probe that uses its interaction between the probe and the material. The interaction between them is measured by atomic force microscopy, that gives an information about the surface roughness. So AFM will be the correct answer. Apart from that, if we see at the other devices like differential scanning calorimetry, that will mostly give information about the melting temperatures or the glass transition temperatures. Two photon microscopy gives an image of the deep tissue, and it is basically a fluorescence microscopy, does not provide an information about the roughness. If we talk about dynamic light scattering, it measures the particle size distributions and cannot image or measure the roughness of it. And circular dichroism It's basically used to get protein secondary structures because it gives information about the molecular structures, chirality of the molecular structures. So AFM, or the atomic force microscopy, will be the correct answer here. Moving on to the next question, the type of hydrogel that polymerize after injecting into the body are called. This question has already been discussed in one of the previous questions, so it should be easy to answer. Option 3. Okay. Yes, all of you are correct. It will be in situ cross-linking hydrogel. As I said before, these are polymers. There are a polymer and a cross-linker basically, and when injected inside the body, it gels there immediately due to changes in the pH or temperature or any other factors. This is a minimally invasive delivery and usually used in defect conditions, mostly to fill an irregular shape or something. It could be used in other settings as well, but yeah, it could be used in those situations to fill a gap where there is a defect. You can inject these two polymers to fill the gap to form a in situ gel there, and then release the drug as well if needed. So in situ cross linking hydrogel will be the correct answer here. Moving on to the next question, what is true for bioerodible matrix delivery systems? You have to select two correct statements here. One is degradable, more patient compliant. Non-degradable, byproduct of degradation will always be highly toxic, or it can achieve first order with surface eroding polymer devices. Which of these options you think will be the correct statements for bioerodible metric systems? Option 1 and 4. Anybody else would like to answer? Okay, so the correct answer here is option 1 and 4. Uh, these are the two true statements for biodegradable matrix delivery systems. One, that is, it is degradable, so that is why it is more patient compliant. And four, it can achieve first order with surface eroding polymer devices. So these were all the questions we had for today. If you have any questions or any other doubts in the questions discussed so far, or if you would like me to go through any of these topics again, please let me know. Otherwise, see you next week. NPTEL exam pattern would be similar to this only. It will be mostly MCQ type questions or numericals where you have to enter a particular value similar to your assignment questions. And what doubts you have regarding the assignments? I am not sure whether your eligibility will be an issue for the exam. You can write to the NPTEL team itself. There will be a FAQ session, or you can raise a query against it to the NPTEL team. They'll let you know whether you'll be eligible or not. I think there are multiple factors, assignments, and other things as well. Scores of the assignments, how the average score will be, mostly it will be dependent on that. So you can write to the NPTEL team to know whether it will be eligible for the exam. If you haven't submitted the assignments, um, no, without submission of the assignments, I don't think you will be eligible for the NPTEL exam. But you can write to the team if anything could be done about it. If you can reappear for the assignments or something like that, you have to ask the team, NPTEL team, about it. You can raise a query. Okay, porosity in non-erodible matrix systems can be measured by which technique? You can use microscopic techniques, mostly to visualize, like scanning electron microscopy, I guess, and there you can measure the size of your pores in those non-erodible matrix. Um, Assignment score can score marks in exam. I'm not sure I understand your question properly. Can you please elaborate? What do you want to know here? For drug delivery in neurodegenerative diseases, which systems would be the best option? It would depend on what, where do you want to deliver these systems for your diseases specifically. What is your site of injection or your site of delivery? Based on that, you can select a system. Um, if you are asking about if you'll be eligible after missing the assignments, you have to write to the NPTEL team. They handle this assignment problems and everything, so they can let you know if you'll still be eligible after missing few assignments. Information assignment score is we get the information assignment score is mandatory. I am not sure I understand your query, Imran, but you can write to the team if you have any doubts regarding the assignments, their scoring, or whether you'll be eligible for the exam or not. And if you want to apply for the exams, you should start submitting the assignments, the future assignments at least. But you have to confirm it with the team. I think where you are submitting your assignments, if you open that portal, there would be an option to raise a query, or in the feedback form also you can write, I guess. Okay, are there any more questions regarding the assignments that we discussed so far, or any other previous assignments? Please let me know if you have any doubts on any of these questions that we discussed today. Otherwise, we can close this session here.